Hey, so today we are talking about Boolean literals. Boolean literals are just raw, true, or false values in your code. Most of the time, if you see a raw, true, or false value in your code, there's probably something wrong. I tend to think of that as a code smell, unless there's like explicit configuration happening where you have to set some flags to true or false, or it's a configuration file that happens to be code, and you're doing, again, flag setting. That sort of thing makes sense. But if you're doing things like in this code where some conditions being tested and then you're returning true or false based on that, that's where things get a little squirrely. And if you see code like that, or if you're writing code like that, you should kind of raise your eyebrow and be like, okay, how can I make this make a little more sense? So today we're working in Ruby. If you couldn't tell already, this is actual code from a real Rails app I came across. I took out all the details that don't matter. This is from a model in a Ruby on Rails uh, program, and uh, I don't know. I'm just going to kind of run through this and let the code speak for itself because I keep wanting to explain things, and I think I'm overdoing it here. So we've got this method voted. Uh, was this thing voted on or not? That all seems to depend on the score, and it hasn't been voted on. It's false. It hasn't been voted on. If the score is nil, it's never been set, or if the score is somehow uh, less than 1. Okay. So what's interesting, just right off the bat, if we come over to IRB, say x equals nil, x dot to I. Okay, so 2i is going to give us a 0 for whether we're nil or not. So the nil check we just really don't need. And so we end up with this sort of situation here where we are mirroring our two conditions, right? So are we less than 1 or are we greater than or equal to 1? Another way we can put this is instead of greater than or equal to 1, we can make this greater than 0 because we're dealing with integers, not anything else. So these are going to be whole number values. So greater than 0, that's going to be 1 or more. Now, for me, when I look at stuff like this, I kind of want to put the true value on top. We couldn't do that before because there was that nil test. I think that's what they were thinking about. They had a nil test, so you couldn't just jump in with your true test and do the 2i because they thought that nil wouldn't work with 2i. But now that we're past that, we can have the true test at the top. And for any Boolean method like this, really the thing you want, if you see this, a Boolean literal that's true, that's kind of the heart of your method. That's the question that's being asked. That's the critical piece of information. So is the score greater than 0? So in other words, is the score 1 or more? So true, otherwise it's false, and we don't even need to have that if. We can just say false. Now, the other thing here that's weird, at least from a Ruby perspective, is this explicit return. You don't tend to have that in Ruby. I mean, you can, and there's sometimes where you want that to do an explicit return, but it's kind of unusual. But what's interesting here is we can eliminate all of that if we just get rid of that, and then that's our method, because Ruby is an expression-based language. This expression is going to evaluate to either true or false. That score is either greater than 0 or not. And if I go back here, that's all we were doing anyway. We were seeing if the score is greater than 0, we return true, otherwise false. But since this guy is going to return a Boolean anyway, we're good to go. So we're done there. And it's the same sort of situation here. But what's interesting is there's this thing called De Morgan's laws, sometimes called De Morgan's theorem. It's just a way of, if you're not familiar with it, you can go look it up on Wikipedia. It's just a way of thinking about and or and not and how they relate to each other. So here you can see we're returning false if we don't have a review or if the review is blank, right? And we're returning true if it's not nil and not blank. And again, I'm going to throw I'm going to throw the true on top just so I can kind of think about where the value is in this method. So since these are mirrors of each other, that is to say that these could be rewritten to be equivalent, I can get rid of that entire expression, and we'll say again, just like we did before, it's true if the review exists and it's not blank, otherwise false. And just like we did before, we can just evaluate the expression, and the value of that expression should give us what we want. We can't simplify this more, I don't think, but we could rewrite this, and that was kind of came to mind with the mention of De Morgan's theorems. De Morgan is basically saying that you can take something like this that's a not and a not, and you can turn that into a not and an or, like this. So you can say, is this not null and not blank? Or you can say, is this not nil or blank? And those two are equivalent. I think this is probably clear enough. So at the end here, we have voted if the score is greater than 0, and reviewed if we don't have a nil, or if our review exists and if it's not blank. Again, I think that's clear. We didn't have to have the Boolean literals. I think the Boolean literals kind of explicitly called out that there was a problem, and we've simplified the code from where we were over here. Even if you're thinking, well, that's all great, but this is still technically correct. The code will work. Who cares? If you have to come back and look at this, you're going to kind of care. All this mess, it's not just 2 lines of code. It's kind of a burden of, you see a false, okay, well, why would that return false? Oh, I've got to go through this whole thing, and then, okay, I see a true, and think about this again. And basically, it's making you think about the same exact piece of logic 2 or 3 times just to understand what's going on. And then, for me anyway, there's always sort of a paranoia when there's multiple expressions like this of like, did I get the whole thing right? When I first saw this, I thought actually there was a fall through case with 0, and it turned out not to be the case. But that kind of cognitive delay, bottom line, costs you time and frustration and confusion, and it's just kind of bad news all over. Boolean literals, not even once.